Hello guys, so let's continue now our discussion about decoder. So the basic consequence is that we take each lecture or each recording or for each circuit or each design. So if we start with smaller design, can we use it to build a bigger design? And the answer is yes. And this is what we're gonna do with decoders. How to implement, higher order decoders, like for example 4 by 16, without going into the details, of constructing a truth table, and such similar stuff. So the idea is really simple, and basically it came from the idea of having the enable. So we're gonna use the enable signal, but for other purpose right now. So let's start by a simple example, which is building a 3 by 8 decoder out of two 2 by 4 decoders. Okay, with enable input, and the resulting circuit has no enable. It will just regular decoder like the ones that we see in our first slide, last lecture or last recording. Okay, so here we have the two decoders. As you see, both are 2 by 4 and both have the enable input. And the idea basically is to connect the enable input for each decoder with the third input. So basically this is 2 by 4 and this is 2 by 4. I mean, each one has two inputs, X and Y. But now we want to build a 3 by 8 decoder, which has three inputs basically, X, Y, Z, or for example, W, X, Y, whatever you call it. Here it's W, X, Y. Okay. So just look at the truth table for the 3 by 8 decoder, and you're gonna have the idea basically how we can use 2 by 4 to construct such 3 by 8 decoder. So here is the third or added variable, the W. Okay, and look, for the first 4 combinations, W is 0. Then the last or the second 4 combinations, W is 1. Okay. And look, here 0, 0, here is also 0, 0. Here is 0, 1, here is also 0, 1. Here is 1, 0, here is also 1, 0. Here is 1, 1, here is 1, 1. Okay. The idea is when you have X and Y, both are 0, 0. But W is 0, you're gonna have D0 equal to 1 and the rest is zeros. And when you flip W, I mean with same X, Y, 0, 0, but W now is 1, you're gonna have another minimum term, which is in this case D4 is 1. Okay. So what we're gonna do is the following. We're gonna get the first 4 outputs, D0 to D3, out of the first 2 by 4 decoder. And the second 4 outputs from D4 to D7 out of the second decoder, 2 by 4 decoder. Basically, this decoder, each one has 4 outputs, because it's 2 by 4. So this line here, which is written in front of it, D0 to D3 or D4 to D7, it's actually 4 wires. Okay. Now let's study what's gonna happen, when we add 0, 0 and X and Y and add W0, for example. So basically we want to D0, let's assume here is the D0, should be 1 and all the rest should be zeros. And here is D4. So we added X and Y 0 and W is also 0. So remember, this 0 will go to the enable, so this enable is 0. So the second 2 by 4 decoder is disabled. So basically all the outputs will be 0. Same W now will be inverted. So we're gonna have 1. So the first enable is 1. So the first 2 by 4 decoder will just act normally. Okay, based on the output, one of the minimum term will be 1 and the other will be 0. So this is 0, 0, this is minimum term 0. So this will be 1 and the rest will be zeros. So look, if you look now at the combined outputs, the 8 outputs, you have 1 and 7 zeros, just like the 3x8 decoders, decoders that we just see, you know, in the previous video. Okay, let's now do the second, you know, the second case when W is equal to 1 this time. Okay, and still X and Y are 0, 0. So 1 now is going to the second enable of the second 2x4 decoder. So the second decoder will act normally. It's gonna look at the X and Y, and those are zeros, and the corresponding minimum term will be 1, and the rest will be 0. So this guy will be 1, and the rest will be just 0. Let's now check the first decoder, the top one. So W now will be inverted, so this guy will be 0. So the enable is 0. So basically all the outputs will be 0. Now look at the green outputs this time. You have, let's rotate it here. So you have zeros from D0 to D3, then D4 is 1, then D5 to D7 is zeros, just like what we want. And you can do the same for any other, you know, combination of the inputs XY and WXY. Okay, the question is, can we do this with 4x16? Yes, and actually 4x16 is more interesting because let's check why. We did in the previous video the 3x8 decoder, right? With enable, we did it. So based on that, you can exactly the same. So you have X, Y, and Z, and here is a W. Again, connected to the enables of the two 3x8 decoders, but one directly, which is the second one, and one with inverter, which is the first one. Just exactly similar to the first one. And in the same manner, you can do, 5x32 and so on. Okay, that's basically how to do, the hierarchical design of decoders. Thank you guys very much for watching this video, and see you in the next video. Bye-bye.